okay, which is also known as our stress average. So this will be equal to stress 1 plus by stress 2 divided by 2. So this will be equal to minus 92.8 plus by 0 divided by 2. So 92.8. So it's 46.4 minus 46.4 megapascal. Okay, so 46.4, I'm going to eyeball this. So 46.4 is somewhere around here. Okay. Right. So this is our this is our stress average point. Okay. Right. So if you have a protractor or a compass, you can start sketching your Mohr circle. So that is over here up to here. Right. So it's about how. So 2, 4, come up by a bit. Okay, so this is your Mohr circle now, right? So we just constructed our Mohr circle, and we also know where point Y is now. So point Y now over here, right? So this is our second value. This is our Y2, right? So Y2, where it intersect the shear, right? By the circle intersect the shear, we can now draw a straight line Y2, right? Oh, I think my circle has some issue. Okay, this is not precise. Or my 46 line is not very accurate. Okay, so I think, wait, 40. Yeah, I think my circle is not very accurate. Okay, so 4.5. Maybe I should string it down a bit. String it down a bit. Okay, so where it intercept. I'm not having very good luck over here. Oops. Anyway, it's just a graphical, okay? If you construct correctly, it has to intercept your 40 line on the shear, but where my circle now is not exactly at the 40 line. I'm a bit off, okay? So I will adjust this a bit. Okay, that's my 46. My stress average of 46.4, okay? Okay, so this is where my 46.4 is. Right, so we have to find our value of Y2. Okay, we have to find our value of Y2. So to find stress Y2, right, to find the stress Y2, so it will be equal to minus 46.4, right, plus by 70, okay, plus by 70. Hold on, it's not plus by, so it's minus 46.4 from the stress average line that we know, and we know that the distance from, so now we know this distance from here to here, right? So all we need to know now is this distance, right, from here to here, because this distance and the distance from here to here should be the same, right? These two distances have to be the same, right? So I will call this omega. Okay, those two distances has to be same. So because it's going to the right hand side, so this is our omega. Okay, this is our omega. So this will be equal to minus 46.4, right? So now we have to find our omega. So omega will be equal to 70, right? So we know that that's our 70 line plus by 70 minus, okay, minus by 92.8. Wait, let me. I'm all of a sudden I'm having issue of finding omega now. So I know this angle is alpha, so this is alpha. So to find, so over here, right? So if this is alpha, this is alpha also. This angle over here is 2 alpha, right? So if we have the angle over there, right? So let's find omega first, plus by omega. So omega, so tangent to alpha is equal to 40, right? 40 divided by omega. So we are focusing on this circle now. Okay, I do apologize for this. We are focusing on this triangle now. Okay, to find omega. So we know the angle made is 2 alpha over there, right? So we found alpha to be 92.29.7. So omega is equal to 40 divided by tangent twice of 29.7. Okay, so this will be equal to 29.7 times 2 tangent, okay, 40 divided by, so it's 23.65. Okay, it's 23.65 6, okay, megapascal. Let me do it again. So 2 times 29.7 tangent, yep, 40 divided by, so it's 23.655. So for this case, stress Y2 is equal to minus 46.4 plus by 23.656. So minus 46.4 plus 23.656 is equal to minus 22.8 or 22.7 megapascal. So that is the other Y2 value. Okay. Now this circle is very unique. Okay, let me explain about this circle is very unique first. Then we talk about is this the right answer. Okay. So if you look at this circle, I want to highlight that X, Y2, and Z share the same circle. Okay, right? It all share the same circle. So this circle belongs to the XY plane, right? It also belongs to the XZ plane. And it also work out that it also belongs to the YZ plane. So it's possible for 3D Mohr circle to be in one circle. But the answer is not valid. I repeat again, but the answer is wrong. Anyone want to tell me why the answer is not valid for this case? It's still within the what? It's still within the no-go zone. Okay, it's still valid in the sense that it is still, oops, I should not have drawn anything this side, right? It's still within the red zone, okay? But why is it not valid? Anyone want to try? Why is it not valid? Why this is not a right answer? Anyone?
Is it because it doesn't go all the way to Tmax?
Well done.
Tmax?
Yep, you are absolutely right down there, okay? And this is absolutely, so the answer is the maximum radius is not equal to what? 75 megapascal. Okay. Because for which the maximum shear has to be what? 75 megapascal. So for this reason, this solution over here, what we see is over here, this is not what? Not valid. Okay, not valid. Now the math for this, there's in fact, this is what I've just done. Okay, you can see the working over here. It's just high school math. Okay, it's nothing like 2ZZ03 that you are doing now. Okay, right? This is very simple math. Okay, so now let's look for the other possible answer. So the other possible answer. Okay, so let's look at the other possible. Again, we're going to construct Mohr circle again. I'm going to use the same scale like before. Bear with me. Okay, so we're going to do Mohr circle again. All right, so now this is minus 160. 80, 60, 20, 40, 60, 80, 100, 24. Okay, so that's our normal stress. Then we go for our shear stress again. Right, so our shear stress clockwise 20, 40, 60, 80, minus 20, minus 40, minus 60, minus 80. Then I'm going to construct our no man's land again. So you cannot go beyond this limit over here, 150 line. Okay, so we cannot go beyond here. And then we cannot go beyond our 70 line. Oh, sorry, 75 line. Okay, so this is our 75. And then our 75. Okay. Then we have our, again, our point Z. This is our anchor. Right, this is our point Z. And then we have our 70 line. Oh, I drew it on the 60, which is wrong. So this is our 70 line. And then we have our 40 line. Okay, so this is our 40 line. So again, we know that this is our point X. So next we're going to do is we're going to pick our principal stress 1 over here. Okay, we're going to pick up principal. So that's our first principal stress. Right? Right? So that's our, so we use the same theory like before, right? Rules of the circle. So if I do copy, I paste, I rotate this by 90 degrees, right? So from here, right, this is my stress 2 point, my principal stress. Okay, that's my stress 2 point, right? So from here, same thing. Okay, we decide to use our alpha. So this is also our alpha. So we're going to do tangent alpha again. So tangent alpha will be now equal to 40 divided by 10, 20, 30, 40, 50, 60, 70, 80. Okay. So alpha is equal to, so 40 divided by 80 inverse tangent. So it will be 26.5 or 26.6 degrees now. Okay. So from here, we can find our stress 2 will be equal to minus 70 plus by 40 tangent 26.6. Okay, so this will be equal to, so tangent 26.6 times by 40. So minus 70 plus by, so this will be equal to minus 50.